Hello. I was hoping to go over this in class Monday, Tuesday, um, but a lot of you guys are going to be taking the AP Gov test and the AP Econ test, so I'm not going to see you. So I'm going to try to make a little video going over the questions that we had the most problems with when we took our practice test. And then we have another practice test available online, so hopefully you get a chance to look at that, take that for the actual test. Taking a look at 26 was the most commonly missed question. And well, that's kind of a bummer. I'm kind of pleased at the same time with some of the understanding I think that was shown in terms of how you missed the question. A lot of people missed the question, and that is when this array gets passed in as a parameter, it's true that it's not actually passed by reference, actually like passed by I don't know, value of the reference or something like that, but it sort of behaves the same way, right? Whereas when you pass in this array, basically what we have is another variable reference pointing to the same object, right? So when I say nums here and it's got 1, 2, 3, 4, 5 in it, and then I pass in nums to this method called changeIt, R is going to be pointing to the same object 1, 2, 3, 4, 5 as nums is, right? So if I change R, I will be, if I make a change to R, say like R index 0 equals 45 or something like that, I am changing the same object that nums is pointing to. And so when I reference nums, you're going to see the change there as well, okay? Now, the trickeroonsky with this question, and I think that's why most people kind of answered the question, is they thought that 0 would be updated in this array here that nums is pointing to. And so when we print out nums, you would see 0, 0, 0. But the problem with this is that we create a new array of size 5. And so what that does is I have these two variables pointing to the same object, right? One of them is called R, but R then points to a new object, okay? That does not take the variable nums with it to the new object. Okay, it's not like those two variables are linked together and they're just going to whatever one does, the other's going to do. They're both pointing to the same object. They're both pointing to the same object. So if a change is made to the object, both of these variables will reflect that change if you refer to them, right? But what this variable R does is we create a new array, and R points to the new array. Well, guess what? Nums is still pointing to the old array. Nums is still pointing to the old array. And that was probably the biggest issue I think most people had, is you put, I think you put B probably as the answer. Now, with primitive types or non-mutable types like strings and ints and doubles, you're going to get like the value, not a copy of the reference or something like that. So it's not, you have no hope to make any permanent sort of changes to, in this case, like value or name. There's going to be no permanent changes that are going to be made to those variables, okay, because they are not mutable. They're not mutable. So it's not like you have pointers going on. You just get the value of the variable, okay? So yeah, so E was the correct answer there if you missed 26, okay, which was the most commonly missed question. All right, so the next most commonly missed question was this concat words question here, where you get an array of words and some starting index. It kind of explains what the code is supposed to do, but you can kind of see it here pretty clearly that if bear, apple, gorilla, house, car are in the array, and then the starting index is 2, what we're going to get is car, house, gorilla. So it looks like 0, 1, 2, right? So in reverse order, we are going to get the strings concatenated, and we are going to get the value at the starting index as well. So it's going to be inclusive of that, right? And so we have to look at these algorithms and see which one works, right? So int k equals start index, k is less than words plus length, blah, blah, blah. So you get result plus equals words k plus words dot length minus k minus 1. So that's kind of interesting. So think like 2. Think for in this example here, if it's 2, that means I'd be adding gorilla first, and then I would go to words at length, which is 5 minus k minus 1. Well, guess what? That's 2 again, and so I'd add gorilla again, and I'd be doing that every time. Well, next time it would be 3, but basically the first time through I would get 2 gorillas, and that would be the first thing added to result. So that doesn't really make any sense to me, and you guys didn't think so either. I think only 3 people said 1 only was the right answer, but that's definitely not the right answer. Okay, how about this guy? Words length minus 1. Okay, that's promising because I want to get the last value first, right? And while k is greater than or equal to start index, okay. Result plus equals words k. Okay, I like this because I'm getting car first, and then k minus minus. Okay, good. So next time k is going to be house. Next time k is going to be gorilla. And I do go in there when k is the start index, which is 2. I want to be inclusive. So excellent. And I think most people identified that that would be a correct answer. 30 people put B as the correct answer. So it said definitely 2 works. The correct answer here is E. So 2 and 3 works. So let's take a look at this one. So I get a new array, which is the length of the original array, called as a temporary array. And then k equals 0, k is less than or equal to words.length divided by 2. So in this case, if it was 5 divided by 2, that would be 2. Okay, and we go k plus plus. And then we say words.length minus k minus 1. Okay, so let's see. The first time, that's going to be 0 minus 1. So it's basically minus 1. So how about this? It seems like I'm getting the last, we get the last value in the original list is going to be put into my temp k, my temporary array, my new array, right, is going to be put in the first spot. So I'm going to take the last value from words and put it in the first spot of this new array, right? And then it says word length minus k minus 1 equals words k. Interesting. So then I'm going to go to words.length minus k minus 1. So that would be like 4, right, equals words k. And that would be the first value. That would be the first value in words, right? So it's like in the last spot, I'm going to put the first thing that's in there, right? And so you're basically kind of doing this every single time. Now you're only doing it like half of the time, right? And I guess in the middle value, I think if it was like an odd number or something like that, you would be doing the same thing, I think essentially twice or whatever. But what's going to end up happening is you're going to build a new array where everything is in reverse order, okay? And that's called temp. And then we're going to say here temp.length minus start index. Well, remember, the length of temp is the same as the word's length. So in this case, it would be 5. The start index is 2. So k equals 0. In this case, would give us k is less than 3. And we say result plus equals temp k. Now remember, temp has got them in reverse order. So putting the first thing from the temp array onto our string sounds good. We're going to put the second thing on there, and then we're going to put the third thing on there, and we're going to get car house gorilla again. So of course, just because it works for like one example doesn't mean it's always going to work. But yeah, just by doing it in the example, it does work for the example, and then you can kind of think about the logic and like, oh, okay, I see what's happening here. You know, like the values are being stored that way. So at first, it did look a little weird, did look a little crazy. I think maybe a lot of people just didn't even bother to kind of try to fight through it. It just looked so weird, but if you really fight through it, it actually did work out. So the second most frequently missed question. I think a lot of people did identify that B worked, but maybe didn't take the time to go through 3 and actually figure that out and see that it did work also. Okay. All right. So the next most commonly missed question was 23. And I think this one is a good paper pencil one. Just try to follow along with everything. So let's try this. Insert item is going to be our index J. And here's our array 5, 4, 3, 2, 1, and j is 1. So how about the first time insert item is going to be 4? K is going to be j minus 1. J is 1. So K is 0 the first time, while K is greater or equal to 0. And insert item is less than RK. Okay. So while 4 is less than what's in the first spot, K is 0. So while 4 is less than 5. So that works. That works, right? That's true. And so now we're going to go inside this loop and we're going to say RK plus 1 equals RK. Okay. So that means I'm going to take in the first index whatever was in the 0 index, right? So that means it's like saying R1 is equal to R0. Well, what's R0 right now? R0 is 5. So now 5 is in that second spot. I go K minus minus. So K at this point would be negative 1, I suppose. And when I come up on that loop, K greater than or equal to 0 is no longer true, right? No longer true. So I'm kind of done with that loop. RK plus 1 equals insert item. So K now, remember, is actually negative 1 at this point. So K plus 1 would actually be 0. So I got R index 0 equals insert item, which is 4. So after one pass, it looks like 4, 5, 3, 2, 1. Okay. Second pass, J is 2. And so I go insert item is R index 2, which is the 3 guy, the 3 spot, right? And, the value 3. K is going to be equal to J minus 1, which is going to be 2 minus 1, which is 1. So K is going to be equal to 1. So I come up here and I say, is K greater than or equal to 0? Yes. Is insert item less than R index K? Well, remember K is 1. So insert item right now, R index K is 5, right? Insert item is 3. Is 3 less than 5? Yes. Okay, so both the while things connect, right? So I'm going to go in there and say R index K plus 1 equals R index K. What that does is it's like saying R index 2, right, is going to be equal to R index 1, which is 5. So again, I'm moving that 5 over one spot. And then we say K minus minus. So now K is 1. And I come up there, K greater than or equal to 1. That's true, right? Is insert item less than R index 1? Well, R index 1 right now is still 5, right? Still 5. So even though we put a 5 into the second index, the first index still has a 5. We haven't really done anything to it. So is 3 still less than 5? Yes, it is. So we now move down the line. Or we don't move down the line. We just or we go in there. We go in there, and K at this point is 1, right? So we're gonna put K and R index 2. We're gonna put what's in R index 1. I feel like we just did that. Wait, pause. Blah, 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 blah. Oh, I'm sorry. K at this point is 0. K at this point is 0. So insert item is being compared to what's in the first spot. That makes more sense. And so what's in the first spot is 4. So yeah, 3 is still less than 4, right? But they say RK plus 1 equals R index K. So what that's going to do is take that 4 and move it to the first index, right? To the second spot, basically. There's still a 4 in the first spot at this point. But now, let's say I complete this loop, this while loop. What I've got is 4, 4, 5, 3, 2, 1. And then the last thing I do when I get done with the loop, again, at this point, K minus minus, K is actually negative. So I say K plus 1 would be 0 again, 0. And so R index 0 equals insert item. That means I put a 3 in the front. So I replace that 4 with a 3. And right now I'm looking at 3, 4, 5, 2, 1. So that is C. Now, this is interesting because I believe this is something called insertion sort or selection sort. Both those algorithms are kind of similar to me. I forget which is which. But anyways, maybe it's insertion sort because it says insert item. But oh, it says insertion sort right there. There you go. So obviously, if you're familiar with the algorithm, maybe you have a better chance to understand what's happening here, and you probably already know what the algorithm does and can do it. But I would argue you actually don't really need to know the algorithm or ahead of time. You could actually just walk through the code and should be able to figure that out just by stepping through it twice. Okay. So that was the third most missed question. Okay, so here's binary search. So we have this algorithm for binary search. We haven't talked a lot about binary search, but it's actually something we talked about in principles last year, if you guys remember. But basically, for binary search to work, right, everything has to be in order, right? Your data has to be ordered. And you're looking for something, right? You're looking for this value. Well, what you're going to do is you're going to start out with the middle index, check the middle index, right? And because it's in order, you can make a decision about whether the value you're looking for is greater or less than that middle index value, okay? And so basically what happens is, okay, they're saying you have a start and an end, right? So at the beginning, 0 is the start, end is like the length minus 1 term, right? And you're going to use those two values together. You're going to add those two values together to get the middle value, right? What happens is if the value you're looking for is greater than what's in the middle index, your start, instead of being 0, your start is going to move to mid plus 1 because I'm essentially eliminating half the data and saying, okay, because the value I'm looking for is greater than the middle value, then I can kind of cut that off. Now my start is mid plus 1. My end is still like the last index, and I'm going to add these two values together. Again, get a middle value, check a middle value, less than, greater than, and I'm either going to move the end down or I'm going to move the start up, but each time decrease the number of values I'm looking for by 2, okay? So if you understand that's the way it works, and you should just have that kind of basic understanding of binary search to answer this kind of question, but a little scary, I think maybe a lot of people didn't have that basic understanding of binary search, and maybe that's why we miss this question so commonly. But what value is returned by the call, binary search call? Well, it should be the index of the target value, but we got 3, 8, so which one are we going to find first? Okay, so that's 0 and 1, 2, 3, 4, 5, 6, 7, right? So 0 and 7, I add those together, divide by 2, that's 3.5, but truncates at 3. So the first value we look at is in the third index, 0, 1, 2, 3. That value is 4, right? The value I'm looking for is greater than 4, so my new start is going to be 1 greater than the third index. This is the third index here. So that's going to be the fourth index, right? And then the end index is still 7. So I'm going to say 4 plus 7, 11, divided by 2 is 5, right? 5. And so again, 0, 1, 2, 3, 4, 5. That's an 8, right? So what value is returned by the call to binary search? 5. Even though there's other values there, the way that algorithm works, it's going to find the one in the 5th index first, right? Correct. Just double checking. Okay, so that's 35. And I think, what's interesting too is I think there was a question related to this, maybe 36. It was also kind of common. Yeah, so this one, if you kind of understand at all what binary search is, should not be missing this question, okay? Suppose the binary search method is called with an array containing 2,000 elements sorted in decreasing order. What is the maximum number of times that the statement indicated could execute or calculate midpoint, right? And so, yeah, so it's right there. So that's again calculating the midpoint, looking at that center value. Well, the way to do this really, first of all, let's hope we don't answer A, B, or E. Like this makes no sense, right? That we would only calculate the midpoint once makes no sense. The fact that we calculate 2,000 times or 1,000 times doesn't make any sense, right? Because what we're doing is we're cutting the number of items we're looking for in half every single time. So the 2,000 the first time is going to leave 1,000 items to look at, then 500 items to look at, then 250 items to look at, then 125 items to look at, maybe even slightly less, but I don't know. And then how about 63 items to look at, and how about 32 items to look at, 16 items to look at, 8, 4, 2, 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I got 12, but I guess maybe that last one, calculate midpoint when you have 2. You don't need to calculate midpoint when you have like only one value left, right? So, you know, if I could see if they put 11 and 12 there, you might be like, oh, which one do I choose? But, you know, I mean, 12 is not 20, right? It's very close to 11. And when I look at it, I'm like, oh, yeah, if it's 2, I don't need to calculate the midpoint anymore. So, any hoozy doozies. Yeah, so if you're familiar at all with binary search, we should be getting 36, and few people miss that. What was kind of crazy to me is, you know what, a lot of people put 27. A lot of people put 27. I think you thought binary, and so you thought like, oh, it's 2,000, so it's going to cut in half to 1,000, maybe. I don't know. But it's the number of times you have to do that. So yeah, that doesn't really make sense. How about 27? 27.